Today I'd like to show you how Power 2 can automate the design process in an engineered-to-order environment. We will see just how quickly and easily Power 2 can take a few simple inputs and turn them into not only 3D models, but shop drawings, sales quotes, bills of materials, and other documents as well. Let's take a look at this conveyor assembly. Some of the things that we'll be changing are the width, the length, the height, the angle, and a number of other factors that are dependent on the use of this conveyor. Let's go ahead and close this and get started. So right from inside of SOLIDWORKS, I'll just open up my conveyor project, and we'll be presented with a user interface that's going to collect a lot of that information. So I'll go ahead and start by entering my name for the customer name. Conveyor width, let's just go ahead and up that to 40 inches wide. I need this to go 14 feet long, and I'll decide that yes, I do want a user console. Now the conveyor specifications, let's just say that I'm going to leave the belt speed per minute at 200 feet per minute. The motor speed will stay at 800 RPM, but I want to change the sprocket diameter to maybe 10 inches, and I want this to be offset from the frame by about 14 inches. Now that mounting frame, I'll decrease that maybe to 30 inches high, and I need that angle to come in at 5 degrees. So I'll go ahead and hit OK, and then Power 2 will take over and do the rest for me. So we'll see that we resize, rechange the angles, the heights on this mounting frame. Then we'll go ahead, pull up a purchase part there, but then go right into the drive gear. We need to resize that, make sure the teeth update appropriately. And we'll start to position those components onto that frame, creating our first subassembly. So that's been done with SOLIDWORKS Mates. We're not using existing configurations. It's being done all generatively. Everything's as though we created it from scratch. So we need to resize, reparameterize those covers and the guards for that chain that we're going to have. But we need to start putting together those top level assemblies. So we resize those rollers, position the end rollers according to our design rules, and then lock them down with those pillow blocks, again according to our positioning rules. And then we need to mate each of those individual idler rollers into place. So we're going to make sure that we have exactly what we need to create this assembly, no more, no less. There aren't any existing configurations with suppressed parts, suppressed mates, anything like that. Nothing's hidden, nothing's suppressed, everything is from the ground up. So we'll put another one of those gears onto this level of the assembly and finish up that top level, that sub-assembly. And then we go into creating our appropriate chain. It's got to have the right angle, it's got to have the right diameter to fit onto that assembly correctly. So once we've designed that, we need to start putting each of these pieces together into our main assembly. We had that bottom sub-assembly, we added that console, the covers, the gears, everything like that, and we end up having a very nice looking conveyor assembly. So if we take a look at this from the front, we see that we do have that 5-degree angle. If we measure the width, everything's going to come out the way that we intended it to. But as we mentioned before, 3D models aren't the only things that we need to create for this design. There's other documentation that needs to go along with it. So we'll pull up some drawings and reports. I have a drawing for the motor and the gear, and then I want the bill of materials, and I want the quote to come out as well. So again, Power 2 is doing this all automatically, taking that repetition out of, saving as, updating references, doing all of that sort of information and those tasks over and over. We're letting Power 2 do it for me. So if I go into that motor drawing, it's a purchase part, so we'll just see 25 horsepower motor and call out some of those unique dimensions that are useful for the assembly of the design itself. So we'll close that and pull up the gear drawing. Now this is a little more important. We changed the scale to make sure that everything was going to fit onto the page. We may have to reposition a few dimensions or the view if we want it to go so that everything is nice and clean. But all of the information that our shop needs to create this is going to be on this drawing for us already. We don't need to add anything additional if we don't want to. So that looks good. We'll go ahead and close that and save it. And we'll also close this assembly. Now, I did mention that we also created that documentation, so we'll just pull up that file location, and we'll see the quote and a report. Now this report is going to be the bill of materials. This is what I want to look at first. Now we'll see that we've got just a little image just to let the users know, okay, what are we dealing with here? And then we've got the product listing, purchase parts, standard parts, custom parts. We can see the quantities and the descriptions should update according to our specific design. So we needed 13 of these idler rollers that ended up being 6 inches in diameter. The 2 end rollers ended up being 30 inches in diameter. And we'll see our frame here, 168 inches by 40 inches, with 13 rollers that are each 12 inches apart. Same thing with the other frame, with the stand, 5 degrees. So everything is in there, everything that we want. We'll also take a look at the quote that got generated with it. So we can see here that we've got the customer name, the order date, which is today's date, got populated, and we have our custom conveyor belt operating at 200 feet per minute with 13 rollers. It's 14 feet by 40 inches wide, and we've got it at a 5-degree angle. It's starting at that 30-inch height, and it's including the user console. And that all came out to be about $1,360. So that entire process took just a matter of minutes, and we went from the user inputs all the way through our entire design, including the 3D models, our drawings, and the documentation that went along with it. And that all took just a few simple clicks. So we can really see just how fast and just how powerful Power 2 can really be, taking a lot of that repetition and turning it into true design automation. That's the power of Power 2.